Hello everyone, I am Karan Mashru. Welcome to this video. In this video, we are going to discuss solution of the problem of the day, that is longest common subsequence. First of all, let us start by understanding the question. So what does question say? It says that given two strings, find the length of the longest subsequence present in both of them. Both the strings are in uppercase Latin alphabets. So we are given two strings, both of them are in uppercase only, and we need to find the length of longest subsequence which is present in both of them, which means the length of the longest subsequence common to both of them. Okay, now if we just understand this term longest common subsequence a little better, what does longest means? It means that the length of this subsequence should be as max as possible. What does common mean? It means that this subsequence should be present in both the strings. And what does subsequence mean? Subsequence is nothing but a sequence which can be obtained from the original sequence by deleting some or none characters from the original sequence. Okay, but the order of the characters remaining should be same as the original sequence. For example, if I have a sequence S is equals to A, B, C, D, E and S dash is equals to A, B, C, is S dash a subsequence of S? Yes, I deleted D and E. Okay, is S dash equals to A, B, D a subsequence of S? Yes, I deleted C and E. Is S dash equals to A, D, B a subsequence? No. Why? Because we deleted C and E, but the order of elements did not remain the same. Okay, and S in itself is a subsequence of S. Okay, we can say that because we didn't delete any of the characters. Now, out of two strings given, we need to find the longest common subsequence in both of them. So basically the string S1 will have a set of subsequences, string S2 will have a set of subsequences. These are the common subsequences present in both of them. Out of all this, I need to return the length of the longest common subsequence. That is basically what is asked in the question. Now let us read a bit further. So if we look at this example, here we are given string 1 equals to ABCDH and string 2 is equals to ADFHR. Okay, so here the output is 3. What can be the longest common subsequence? ADH and ADH are present in both of them. So the longest common subsequence for this and this is ADH of length 3. Okay, out of all the common subsequences, this is of maximum length. Now if we see here, the answer is 2. The longest common subsequence between both of them is AC. A is also a common subsequence between both of them. C is also a common subsequence between both of them, but their length is only 1. Out of all the common subsequences, I want to return the length of the maximum. So AC is the maximum of length 2. Okay, our task is to complete the LCS functions which take two strings respectively and return the length of the longest subsequence present in both of them. Expected time complexity is length of string 1 into length of string 2, and expected auxiliary space is also length of string 1 into length of string 2. Now let's see how we will proceed in this. So now if we talk about the brute force approach to solve this function, see what we can do is, for each string we can consider all the subsequences of them, and out of all of the possible pairs we can find the longest common subsequence, right? We can do this by recursion. How we can do this by recursion? For each string I'll move from last character to first character and I'll consider whether to take the particular character or not. For example, in the main function we will call longest common subsequence between S1 and S2. S1 is of length n and S2 is of length m. Okay, now in the recursive function, longest common subsequence between string S1, S2, length L1 and length L2. So I need to recursively decide whether to take a particular character into my answer or not, longest common subsequence, right? So what I am doing is, from the last character I am moving. So initially this would pass n and m. So it would be longest common subsequence of string S1, S2. Suppose the length of first string is 4 and length of another string is 5. So suppose I decided to take the last character the fourth character from S1 and the fifth character from S2 into my answer. Suppose they both are matching, they are a common character, then I will call longest common subsequence of S1 S2. Now S1 consideration length is only 3 because the last character I have taken into consideration. So now I have to worry about the first 3 length sequence, and similarly here it would be 4. So in this way what we will do, we will call recursive functions until either of them becomes 0, because as soon as one of them becomes 0, now that function should return what? 0, because longest common subsequence between string s1 s2 0, and let's say here the remaining length is p, is always 0, because if one of the string is empty, then the longest common subsequence between both of them will be empty. So we will keep continuing this recursive calls. Now we need to think about what would be the base condition here and how would we call the recursive functions, right? So that we get the answer. Now understand here one thing. If I am considering L1 length of S1 and L2 length of S2, I have to decide about the L1th character of S1 and the L2th character of S2. Then I'll recursively call on the smaller string, right? If the last character of both the strings match, the best possible thing for me to do is to take them into my answer, that is longest common subsequence. Why? See, suppose I have to find longest common subsequence between A, B, C, D and P, Q, D, right? So at present I have to think about these two characters and then recursively make a call on smaller strings. Since they both are matching, the best thing for me to do would be the longest common subsequence for both these strings is nothing but 1 plus longest common subsequence of A, B, C and P, Q. Because D was matching in both of them, I consider it in my answer, and that is why I am getting here 1 length 1 plus, because 1 is what I have taken D into my longest common subsequence. Okay, now so this is the best possible thing. There might be cases where if you do not consider if you have last characters matching and if you do not consider them into your answer, still you get the optimal solution, but you cannot get better. This will always be the best case. Okay, so here if I do not consider D into my answer, I would not get the optimal solution, right? But in other cases, for example, longest common subsequence of A, B, D, D and P, Q, D. Now this D and this D is matching, right? But suppose I do not want to take this pair into my answer. Then what I can do is, I can say this is nothing but longest common subsequence of A, B, D, D, comma, P, Q, or longest common subsequence between A, B, D and P, Q, D. And this would be nothing but max of both of this. Here what I did was D was matching, so I took it, I considered it in my answer, so 1 plus LCS of the remaining strings. Here I didn't consider this pair into my answer, so either I will remove this, I will neglect this, or I'll neglect this. There is no point neglecting both of them at a time, right? So it would be max of longest common subsequence of, I'll keep it this as it is and I'll neglect one character from here, or longest common subsequence between I neglected one D here and kept this as it is, right? Now this can still return me 1 because D and D is matching. So I will get the answer 1, which is the correct answer. But it is not better, like even if I consider this D and this D as my answer, I would still get 1, right? So whenever we are doing a recursive call and if the last characters of both the strings which we are considering are matching, we will immediately add it to our answer, right? So that would be the best case for us. So how can I write it? If S1 of L1 minus 1 is equals to S2 of L2 minus 1, right? We are considering L1th and L2th character, but their indexes will be L1 minus 1 and L2 minus 1 because strings are 0 based index. Then I can say return 1 plus longest common subsequence between S1, S2, L1 minus 1 and L2 minus 1, right? Else, if they do not match, then return max of longest common subsequence of S1, S2, L1 minus 1 and L2, or longest common subsequence for string 1, string 2, L1 and L2 minus 1. Here I neglected one character from S1, here I neglected one character from S2, right? We should not neglect both of them because that would not be proper. Suppose I have A, B, C, D and I have P, Q, D, E. Now these two are not matching, but if I neglect both of them at a time, the D and D which were matching will also be lost. So if they are common, we will return 1 plus longest common subsequence of L1 minus 1 and L2 minus 1 length. Otherwise, we will return max of this case or this case. Is this much clear? And what will be the base condition if L1 equals to 0 or L2 equals to 0? Simply return 0. And here I will store this in my answer. Now, this is the recursive approach. But what would be the time complexity of this? In the worst case, it would be time complexity would be big O of 2 ki power n into m, because there would be 2 ki power n subsequences of string S1, because for all n characters I will either take it or not take it into consideration. Similarly, there would be 2 ki power m subsequences of string S2. So total time complexity would be 2 ki power n cross m, and it will give us time limit exceeded. So we need to think of some better approach. Now, here the time complexity is exponential. We want to convert it into polynomial, right? Expected time complexity was also length of string 1 into length of string 2. If we can somehow tell that this problem satisfies overlapping subproblems property and optimal substructure property, can we say that this can be solved using dynamic programming? So now, first of all, does this satisfy optimal substructure property? What is optimal substructure property? It tells that if we are using the optimal solutions of subproblems to solve the bigger problems, the problem is said to have optimal substructure property. If we look at the recursive call, we are using the optimal solution for length L1 minus 1 and L2 minus 1 to solve the problem for length L1 and L2. We are also using the optimal solution of this and this. So we are using optimal solutions which we got for sub problems to find the answer of large problems. So we have the optimal substructure property. Do we have overlapping sub problems property? Let us find out. So now we proved that it has optimal substructure property. What about overlapping sub problems? What is the meaning of overlapping sub problems property? When we are doing recursive calls, in the recursive calls, the same sub problem is solved multiple times to solve the larger problem. So here we say that the sub problems are overlapped. So there has been overlapping sub problem property. So for example, if I am saying A, B, C, if I want to find longest common subsequence between A, B, C and P, B and R, then since the last character do not match, I will call longest common subsequence of this is nothing but max of longest common subsequence of A, B, C, comma P, B, or longest common subsequence of A, B, comma P, B, R, right? It would be max of them. Then from here, since the last character do not match, I'll say the answer to this is nothing but max of longest common subsequence of A, B, C, comma P, or longest common subsequence of A, B, comma P, B. Similarly here, since the last character do not match, I'll say the answer to this sub problem is nothing but max of longest common subsequence of A, B, comma P, B, or longest common subsequence of A, sorry, the longest common subsequence of a comma pbr, right? Now here you can see we are solving longest common subsequence for ab comma pb. Here also we are solving the same thing. So the same sub problem is solved multiple times in the recursive call to solve the bigger problem. So it also has overlapping sub problems property. So we can solve this using dynamic programming. Now here we are going to solve this problem using dynamic programming and using the tabulation approach of it. So we will fill out the whole table considering the sub problems and then we'll return the answer. Now what would be our table structure or the array which we will take consider? Now if you look at what we are basically doing, longest common subsequence of the this and this is nothing but longest common subsequence of abc comma pb, which means that at each and every particular point of time we want to find longest common subsequence of length L1 and L2, where L1 is nothing but the length of the prefix of string 1 and length L2 is nothing but length of the prefix of string S2. So we want to find the longest common subsequence from a prefix of S1 and from a prefix of S2. So what I can do is, can I take one table of size n plus 1 and m plus 1, dp of n plus 1 m plus 1, where dp of ij will denote the longest common subsequence length considering I length prefix of string s1 and j length prefix of string s2. This it will denote. So ultimately what I will return dp of nm, which is nothing but the longest common subsequence considering end length prefix of string s1, that is nothing but the whole string, and similarly for string s2. Now I need to fill this table. What would be the base condition? Base condition is when either of the string is 0, the answer to the longest common subsequence is 0 when we are considering a 0 length subsequence of any of the string. So I can say for I equals to 0 to n, dp of I0 is nothing but 0, because if I am considering 0 length subsequence of second string, the answer would always be 0. Similarly, for I equals to 0 to m, dp of 0 comma I is nothing but 0, because if I am considering 0 length prefix of the first string, then the subsequent length would also be 0. Now we need to fill the remaining columns. I can fill them using this two formulas. So further I can write for I equals to 1 to n and for j equals to 1 to m, if s1 of I minus 1 is equals to s2 of j minus 1. If the characters are matching, we will take them into answer. So this is nothing but dp of ij would be nothing but what? 1 plus dp of I minus 1 and j minus 1. As we saw in the recursive call, if they are matching, we take 1 plus dp of the remaining strings, right? Else if they are not matching, then dp of ij would be nothing but max of, we will neglect one character from both the strings in different cases, so it would be dp of I minus 1 j comma dp of I j minus 1, and in this way the whole table will be filled, and at the end what we will do, we will simply return dp of nm, which denotes nothing but the length of the longest common subsequence considering n length prefix of string 1 and m length prefix of string 2, which is nothing but the whole string. Now let's look at the actual implementation and then submit the code. So here is the actual implementation. What we have done is, in the input we have nm string s1 and s2. So I have taken dp of n plus 1 m plus 1, initialize the base cases to 0, and this is the code as we discussed just before, and then at the end we will return dp of nm. Now let's submit it. So let us submit the code. So we have solved this question successfully. Now if we discuss about the time complexity and space complexity, what would be the time complexity? It would be big O of n into m, where n is nothing, n and m are nothing but length of strings s1 and s2 respectively, because we are here running two loops, one inside the other. And what would be the auxiliary space required? The auxiliary space required is nothing but also big O of n cross m. Why? Because we are taking a table dp of size n plus 1 cross m plus 1. I hope you understood this question completely. Thank you.